fast in there. So the stimulus hits it and it runs at about a meter per second, so it's flying. The depolarizations are going quick. You have to remember last semester, sodium gates are opening and you're depolarizing cells and they start to fire out around the whole thing. So now these cells fire, and when they fire, they start to contract. So the atria start to contract right after that SA node has stimulus. Okay? So we're pushing blood to the bottom, right? It sends it across to the other side, and the same thing's happening on the other atria, on the left atria. It's just like a wave. Why is it a wave? Because of intercalated disc. Because what one cell does, the next cell does. Because what cell does, the next cell does. And it's fast, 1 meter per second. My God, a meter's that long. And there's 1 second, it's there. So this is, you can imagine how fast the cells are firing. Okay. The main impulse goes on down, though. While these are doing that, this goes on and moves on up and hits the atrioventricular node or the AV node. Where is it? It's in the septum, in between the superior part of the septum on top of the two ventricles. It's in the middle of the heart, so it's hard to describe where it actually is. And again, if you took a microscope slide in there, you wouldn't know what you're looking at unless you were really good. It looked like cardiac muscle. Okay? The AV node is bigger, and right here it slows things down. You don't even know. It says in your book exact numbers. It goes about half speed, from 1 meter per second to a half a meter per second. A half a meter is that long in 1 second, it's still real fast, right? So now you're stimulating this thing. But unlike here, it's closed off. It doesn't send a signal out like that. It sends it down this bundle of branches. It sends it down the AV bundle. So it doesn't spread like this one. It's closed off. We've got a membrane there. It doesn't let it do it. And the impulse goes from here down the line. And it sends it down the line half a meter per second. What's this one still doing? This one's almost finished now, right? It's gone all the way. And all the blood has now poured down in the ventricles. And we can probably say we're right in here somewhere. None of this is doing anything. It's shielded. And now we come out into, oh, what a name, Purkinje. The Purkinje fibers are located where? In the apex of the heart, in the myocardium. The bundle branches are located in the septum. The AV bundle is located in the septum. So it's not sending the message into the ventricle itself yet. And once the Purkinje fibers fire, they start to do this. Radiate out all over. So the ventricles contract from where to where? From the apex up. Or in other words, from the bottom up, so it squeezes the blood this way. And left to the body, right to the lung. I got it backwards. Right to the lung, left to the body, all at the same time, and you squeeze up. Then you start all over. If you're working just right, 7 minutes to 80. If you've got the right little flicker going from your medulla oblongata, 78 beats per minute. That's an SA node firing. Probably all on this room are like that. Anybody got a pacemaker? Nobody's got it. Some people are based by here, and I wrote all that down. I don't know that I have it on the PowerPoint. Somebody read it. I like this stuff, so I don't know that I'll have it on the test, but I like to tell you. No, don't have to wait time. But you have to know there's a difference in time, or it all happens. In other words, we can't have this, right? We can't have all contract, relax, all contract, relax. You could be in a problem. Or what about the ventricles? If they contracted from the top down, you'd have big trouble, right? If the ventricle contracted like this, well, it would be a real mess. Okay, where did I write this stuff down at? My great handwriting. It's coming, it's coming. Right there. Right there. No, I can see it. I got good light right here. Oh, here we go. Sinus rhythm. A sinus rhythm set by the SA node. The normal way is 70 to 80 beats per minute. You've got to know that one. The normal heart rate, 78 beats per minute, is set by the SA node. That's the way it's supposed to be. But lots of people are alive with other ones. The word for all over is ectopic.
Is that also in the book, ectopic?
I think it's in the book. I get this from Valley Rapids sometimes from doctors. They tell me stuff and I like it, so I write it down. An ectopic foci or ectopic focus means somewhere that's not where it's supposed to be. If you have an ectopic pregnancy, it means the baby came out of the fallopian tube and landed somewhere it's not supposed to be. Ectopic is where it's not supposed to be. There's one called a nodal rhythm. A nodal rhythm is set by the AV node. It's set here. If you have a nodal rhythm, your heart beats normally at 40 to 50 beats per minute. Can you live? Yeah. Can you run marathons? Your heart's gonna, you probably live longer. If you got a 40 beat per minute heart rate, man, you're feeling like you just wouldn't be able to do much. Because that's your normal heart rate. It's not enough to keep you going. It's not enough. Alive, yes. Running a race, no. People with that, I don't know that they probably get pacemakers. They don't go on like this. But you can live. With a nodal rhythm, it's set at the AV node. The normal beat from a nodal rhythm is 40 to 50 beats per minute.
We need to know that?
No.
So if it's wrong,
I'm not going to have some.
so if it's wrong, you say it's contract as well?
On track is this one.
No. Like to contract as a whole part, or?
Well, if the focus is coming from here, it goes backwards. So if this is setting the rate, it can't do it right because it's going to go the wrong direction, right?
No,
So
I'm
it makes
saying
sure,
it's normal.
if it's normal, it's coming from here. There's no such thing as a normal coming from here, it's wrong. But can you live? Yes. Will your heart beat right? No, it'll beat 40 beats per minute, which would be like this.
Yeah, but when you said it contracts from.
It was, yeah, I would still do it the right way. It would still go the line and beat right. It would just be slower. No. If you contract all at the same time, you can't do it, right? It has to be rhythm because you got blood coming in, you got to feel here, you got to contract this first, you got to contract this second. It has to. You can't go all at once. You're having a heart attack if that happens. Okay, the last one is an intrinsic ventricular rhythm. It's set by the Purkinje fibers, and that beats at 20 to 40 beats per minute. You definitely have to have a pacemaker. If this is setting your rhythm, you would have to have a pacemaker. But you can live a while. Okay, learn the normal one for the test. The normal one is from the essay, right? This is the whole thing right here in the picture. It's a sinus rhythm. It's a sinus rhythm. A sinus rhythm is 78 beats per minute, set at the SA node. Here's, well, that's just too much to look at it. Medulla oblongata, wired from here to my heart. Vagus nerve from last semester. Signal, fires, gates open, depolarized. 1 meter per second, flying across there. All these cells are going at the same time. It heads down from the bundle into the bundle branches to the Purkinje fibers. The Purkinje fibers hit the myocardium, and they cause this same picture up here to do from the bottom to the top. That's your normal heartbeat rhythm. So it would be from SA node to AV node to AV bundle to bundle branches to Purkinje fibers and done in that order for normal heart. Nobody had one of those. They're really cool now, man. They got